In this demo, we present Microsoft Stream Insight through an example of its real-time spatial-temporal stream processing capabilities. At Microsoft, there's a transportation shuttle system that moves employees between buildings across campus. With GPS devices and wireless transmitters installed in these shuttles, here's what we can do. We can track and visualize shuttle locations as shuttles move across campus on Bing Maps. Because Stream Insight is a full-fledged relational engine, here's an example filter query that filters the incoming stream of GPS data by a given shuttle ID, shuttle number 755. As shown on the screen, the track shuttle is painted in green. The next query is another example of a filter query. However, this query represents a spatial filter. A geofence is defined to surround the parking zone of building 34. Once a shuttle enters the parking zone geofence, an action can be taken. For example, the employee waiting for the shuttle is alerted. This query is also an example of an aggregation query. The query counts how many signals are received in this parking envelope over the past sliding window of 1 minute. Because a single shuttle keeps sending multiple signals over time, the following query represents an example of grouping shuttles by their shuttle ID and counting the distinct number of shuttles within the geofence. Again, this query shows another relational capability of the Stream Insight relational engine. With an integration of the spatial capabilities of Microsoft SQL Spatial Library and the real-time processing capabilities of Stream Insight, this following query continuously monitors the distance between my current location and all shuttles being tracked. Then, a top K query would reveal which shuttle is the closest to me, or a small subset of shuttles that qualify to pick me up for a scheduled trip. In this query, the distance is computed according to the Euclidean distance. Closest shuttle is marked on the screen as blue. However, in practical scenarios, a much more complex logic is used to schedule the passenger pickup. The logic would pick among the closest shuttle, the shuttle that has a vacant seat, that is headed in the right direction, and will transport the passenger in the shortest possible time, and probably the one that has the most fuel efficiency. Such complex logic is hard to express in a declarative way. Hence, and thanks to the extensibility framework of Stream Insight, complex logic can be written in C# and wrapped with Stream Insight interfaces integrated as a user-defined operator within the query pipeline. The shuttle marked in black on screen is the shuttle that has been picked up according to the user-defined logic. On the analytics side, the following query computes the percentage of idle shuttles. An idle shuttle is a shuttle that has no passengers aboard or no tasks scheduled. At real time, Stream Insight continuously monitors the percentage of idle shuttles. As you can see on the screen, more than half the shuttles are idle. These analytics are crucial from a management perspective. The same analytics query can be made more fine-grained, say on a per-region basis. As you can see on the screen, a heat map now represents how overloaded shuttles are in each region. The darker the color, the busier the shuttles. The lighter the color is, the less loaded the shuttles are. Stream Insight helps in real-time decision-making, which would result in load balancing across campus.